we're going to prove that 4n to the power of 4 plus 3n cubed to the power of 3 plus 2n squared plus n is in big O of n to the power of 4. So remember, I want to make what's here, I want to kind of make it look like something like this. And then what I want to do is I want to chain together inequalities and then add over those inequalities. Because once I have that, like my buckets, I get the chain of reasoning I want for a desired n. And you'll see quite quickly how n0 pops out of this reasoning. And I want you to also notice that when I break them down into those atomic pieces of inequalities before I add them all together, each one of those is very easy for you if you need to further demonstrate that each one is true. The point is that you're summing over the inequalities to derive the overall inequality. Okay, what do we normally do? We state what we're going to prove, right? We need to find a positive real constant, constant C, and positive integer constant, constant n0, such that for all n greater or equal to n0, 4n to the 4 plus 3n cubed plus 2n squared plus n is less than or equal to c times n to the power of 4. Does anybody have any ideas of what I should pick for c? Does anybody see it? What should c be? Well, last time, did you see how I got c? I looked at the coefficients of the polynomial that I was looking at. At that time, I had a quadratic with some linear term there. So maybe I should look at this, and maybe I might have a general pattern I can use. And that might give us a rule that we would like to have. So let's see here. I want you to think about this. You see it? Well, I'll give it some reasoning here, and this will hopefully help spill out what C should be. I'm going to pick C is equal to 10. Then we need to find n0 such that for all n greater or equal to n0, 4n to the 4, 4n to the power of 4, plus 3n to the power of 3, plus 2n squared, plus n is less than or equal to 10 to the power of 4. Well, 10 times 10 to the power of 4. Well, here you're going to see quite quickly. I'm going to use the same strategy. Well, observe that. So this, like I said, you'll notice that a lot of these arguments I use rely on an observation. They rely on an observation. So what I'm going to do is I'm going to try to turn this right-hand side into something that looks like the thing on the left-hand side, but with different powers. And if the powers are more dominant than the ones for each individual term on the left-hand side, we're done. Then I can find n0 pretty quickly. Well, observe that. Actually, I'll try writing it here. Let's see how small I can write this. observe that 4n to the 4 plus 3n cubed plus 2n squared plus n is less than or equal to what? I'm going to rewrite that in terms of different terms that are powers of 4. 4n to the 4 plus 3n to the 4 plus 2n to the power of 4 plus n to the 4, which this is equal to 10 times n to the power of 4. You see where c came from now? All I've done is I've distributed 10 n to the power of 4. I split it apart into these 4 different terms. Then what I'm going to do is I'm going to compare each one of these against each one on the left-hand side of the inequality. Now here's the part where I justify it. So I'm saying observe that this is true for all n greater or equal to 1 as, sort of going all the way over here. Hopefully I didn't attack the microphone there. As, now here's the reasoning, 4n to the power of 4 is less or equal to 4n to the power of 4 for all n greater or equal to 1. 3n cubed is less than or equal to 3n to the power of 4 for all n greater or equal to 1. You see how this one's true? You just divide by 3n cubed, right? Then you get n is greater or equal to 1. And then we have 2n squared is less than or equal to 2n to the power of 4 for all n greater or equal to 1. And that n is less than or equal to n to the power of 4 for all n greater or equal to 1. So I'm just using the same trick, remember. It's nothing too crazy. I'm just trying to make what's on the left-hand side of the inequality look like something I could put on the right-hand side. That's how I pick C. I find picking C makes things much easier when you're dealing with things like polynomials. So now this is my justification. What's n0? I'm just going to choose n0 is equal to 1, right? You'll see that if you pick C appropriately a lot of the time, you might get n0 being 1. That is not always true for general functions, but you'll find that I'm going to give you a recipe that you could use for any polynomial of a form like this. So, like I said, this is all just a big set of tools I'm giving you that you could tackle any polynomial. So, here we go. Therefore, by the definition of big O, now let me write all that out, 4n to the power of 4 plus 3n cubed plus 2n squared plus n is in big O of n to the power of 4. And we're done. Notice, remember, same structure. Notice I'm just doing more complicated examples now, but they're all based on the same idea. I try to make something look the same on the opposing side. Whatever's in that big O, I want to make that look like what's over there. And I may have given you a recipe to do that quite quickly. So I say what I'm going to do. I pick C or n0. I don't have to pick C first. Pick n0. I just find C is much easier to work with than n0 if you know what you're looking for. That's the intuition. Because not every mathematical proof just kind of spells itself out when you see it. Oftentimes, sometimes, computer scientists, mathematicians, they could sit there for months trying to prove a claim. These guys, they're nice and cute. But they aren't obvious the first time you look at them, and that's cool. That's perfectly fine. When you first learn something, don't expect yourself to feel like you've already mastered it. It takes time to learn things like this. So hopefully you'll see that we're starting to build actually a tool that we could use to prove any one of these claims. Now I'm going to give you the tool.